In this video we are going to talk about the DHCP server, but more particularly about the DHCP relay server and how to exploit it. But before we get started, here is a quick disclaimer. This video is intended for educational purposes only. The methods and techniques demonstrated should not be used maliciously or for unauthorized access to networks. Always obtain proper permission before conducting any form of networking testing and security research. So, what exactly is a DHCP server and how does it work? Before we are going to talk about the DHCP server, we need first to understand what DHCP is. DHCP, aka Dynamic Host Configuration Protocol, is a network management protocol used for dynamic assigning IP addresses to devices or nodes on a local area network. New devices that attempt to connect to a new network must introduce themselves first in order to get internet access. That is where our DHCP protocol comes into play. First, the device sends a DHCP discover message to identify available DHCP servers. Second, the DHCP server responds with an offer of available IP addresses. Third, the device then requests a specific IP address from the server. And finally, the DHCP server acknowledges this request and completes the IP allocation cycle. This sequence of steps is known as the DHCP handshake. It is a critical communication exchange between the DHCP server and the client, where the client is typically the device attempting to join the network. After a successful DHCP handshake, the device is now stored in the DHCP client table. The DHCP client table contains information about the devices connected to the router either wired or wirelessly. It displays the name of the device, the interface it is connecting to, the duration until the connection expires, and the assigned IP and MAC addresses. Moreover, the DHCP client table size is 256, but he only can store maximum of 253 DHCP clients. This limit is primarily due to the addressing constraints of the IPv4 protocol. In a typical Class C subnet with a 255.255.255.0 mask, there are 256 possible addresses. However, the first address is reserved as the network address, and the last address reserved as the broadcast address. Additionally, one address is typically used for the router, leaving 253 usable addresses for the DHCP clients. Now that we know the basic principles of the DHCP server, we can continue to the next section. DHCP common attacks. DHCP suffers from several attacks. One of them is the DHCP starvation attack. This type of attack occurs when an attacker sends more requests for new IP addresses than the DHCP server can handle. As I mentioned before, the DHCP client table is limited to 253 addresses. If we are going to use this attack, the DHCP client table will try to make a rotation of the devices in the table. This means that older devices in the table will disconnect and make space for the new virtual devices in the queue. The main result of this attack is to deny legitimate clients to be assigned IP addresses due to the overload caused by malicious requests. But this attack is less important to us because we have a different goal that we want to achieve. We want to crash the DHCP server, completely crash it, not just temporarily overload it or deny its service. The main benefit of crashing the targeted DHCP server is to manipulate the DHCP relay agent and disconnect every device on the targeted DHCP server. The DHCP relay agent provides a way for DHCP clients to communicate with DHCP servers when none are available in its local subnet. A relay agent uses IP routing to forward discover messages to a provisioned DHCP server. The relay agent then relays the DHCP offer back to the client network. When we hopefully crash the targeted DHCP server and create an exact mimic of the DHCP server, the DHCP relay agent will redirect every device in the network that wants to connect to the crashed DHCP server to us. Because one important thing to remember is that every device that got disconnected will try to connect back to the DHCP server again no matter what. And because the targeted DHCP server is crashed and we have an exact mimic of the DHCP server, all the devices that were disconnecting due to the crashing of the DHCP server will connect to us, and we will gain a full control of the network. So to make it work, we will need to use the following attack. DHCP flood attack. In a DHCP flood attack, an attacker floods the DHCP server with numerous DHCP discover requests using spoofed MAC addresses. The main goal is to blow up the DHCP server, consuming a large amount of its resources to lead to server crashes. Unlike the previous attack, flood attacks aim at crashing or slowing down the server, while starvation attacks focus on depleting resources to deny service to legitimate users. For the purpose of demonstrating an attack, I will implement various methods of flood attacks targeting a simple network setup, where the router also functions as the DHCP server. I have developed a Python stress testing script designed to simulate various flood attacks. The script includes the following attack simulations. First, HTTP flood attack generates a high volume of HTTP GET requests aiming to overwhelm the target server with web traffic. Second, DNS flood attack focuses on bombarding the target with DNS queries, intending to saturate the server's capacity to resolve domain names. Third, port scan, repeatedly scanning the top 100 ports on the target. And finally, ICMP flood attack generates a multitude of ICMP echo requests, commonly known as ping requests, to flood the target with ping traffic. After running the script and targeting the router, I only managed to slow the traffic and not crash it. So, I started to think, what can I do to make it to crash? After a short time, I got an idea. Why not to run this script on multiple devices? If this script will run on 20 different devices, it will definitely crash the router, and I was right. I launched 20 containers that contain the stress script to continuously execute the attack against the router. Eventually, the sustained attack overwhelmed the router, leading to its failure, and I was able to crash the DHCP server. Now, we need to make a mimic of the target DHCP server. I found a GitHub project that implements the DHCP server, and I made a few changes to make the DHCP server get a specific interface and IP address. Next, we can use Nmap to find the router's IP address and change our mimic DHCP server IP address to the discovered IP. And there we go, we manipulated the DHCP relay agent to redirect the devices to the mimic DHCP server. I hope you found this video interesting, and if you do, please make sure to subscribe for more ethical hacking content that will be coming up in the near future.